Greetings, everyone. Today, I am headed back to the shop to do some more sheet metal work. We are working on a local restaurant installing the makeup air system and for the kitchen. And what the makeup air system is, we have a duct heater on the roof that pulls in air from outside, and we are ducting it down through the roof into the kitchen and distributing the air around the cooktop area. And the goal is to equalize the pressure between all the air that's being pulled out of the kitchen from the exhaust fans and what we are going to be putting back into the kitchen with the makeup air system. Yesterday, you probably saw a quick video of Wyatt soldering the roof flashing, where our ducting will go from the roof down through into the kitchen. I showed him how to solder sheet metal, and he was an absolute natural. So I will never have to do that again. I'm going to let him do it. Here is a screenshot from yesterday when Wyatt was soldering the rooftop flashing. Today we are going to fabricate up some square ducting, but we have 3 elbows, 90-degree elbows that we have to create. And so I'll show you how Wyatt and I fabricate up those 90-degree elbows in the square ducting. We have to make a couple of turns before we turn and go down through the roof. So let's get going on that, and I hope you enjoy this. Here is a picture of the square 90-degree elbow that we are building today. The A and B measurements are going to be the same at 29 inches, as well as the C and D measurement. So it's a 29-inch square duct. The throat, which is the E and the F, is going to be 6 inches long on each side. So we are going with 29-inch duct because it needs to be insulated since it's outside, and we're using 2-inch insulation inside the duct. So we'll actually lose 4 inches off the 29 to make it a 25-inch square, which is the size of ducting that we need for the proper airflow to feed the kitchen makeup air system. We are using 36-inch wide sheets of steel, and my pattern that I need is going to be 35.25 inches by 35.25 inches. So I scratched a line across the bottom of this sheet, and I'm just going to cut off the 3/4 of an inch excess before I start laying out the pattern of the elbow. I set my marking tool at 1/4 of an inch, and I'm going to scratch a 1/4 inch line on 2 sides of this elbow where I will need to bend the sheet metal up 1/4 of an inch, 90 degrees, in order to later assemble this fitting. The other 2 sides get a 1/2 inch mark scratched along them where the straight pieces of duct will connect to each side of the 90-degree elbow. The 1/2 inch scratch delineates the overlap where the 2 ducts will come together. Now I am measuring out the throat of the 90-degree elbow, which is 6 inches in each direction, but I also have that other little 1/4 inch that I need to add. So I'm marking the sheet metal 5 3/4 inch in each direction. So when that 1/4 inch gets bent up 90 degrees, there'll be 6 inches on each side of the throat of the 90-degree elbow. Here I am scratching the 1/4 inch marks on the throat of the elbow. At the same time, Wyatt is notching all of the corners of the pattern where those scratch marks come together. Wyatt has now taken the pattern of the elbow over to the break, and he is going to bend some cross breaks on the side of it, and those cross breaks basically stiffen the side of the elbow so you don't get that oil can sound from like the metal popping in and out when the fan turns on and off. Wyatt is now going to flip the pattern over and put a cross break in the opposite direction, which will then essentially level the pattern back out to be flat. Now he's going to flip the pattern back over and bend up those 2 1/4 inch sides up 90 degrees. Next, Wyatt's going to bring the pattern back over to the table and use the hand seamers to bend up the 1/4 inch 90 degree turn on the throat sides of the pattern. Next, I'm going to fabricate some standoffs to hold the turning vanes inside of the 90-degree elbow. I call it a standoff because it basically holds the turning vanes 2 inches off the side of the elbow, so we could slip 2 inches of insulation underneath the turning vanes. If we had just mounted the turning vanes directly to the side of the elbow, there would be no insulation there, or if we squish the insulation, it would no longer be 2 inches thick and it wouldn't have the same R value. Here is a good description of why we use turning vanes in a 90-degree square elbow. On the top, you can see how the air is flowing upward and it ends up crashing into the other wall, swirls around a little bit before it finally starts heading down the duct, and that airflow is very inefficient. The lower diagram shows how the air travels through the duct, hits the turning vanes, makes a smooth turn, and continues down the duct, which is much more efficient. Here is what the standoff looks like on the side of the pattern of the elbow. I'm going to use a spot welder to tack this on to the side of the sheet metal pattern. While I finish spot welding the standoffs on the sides of the elbows, Wyatt is cutting the turning vanes to 25 inches in length so they will fit inside of the ducting. Here I am cutting a 4.5 inch wide piece of insulation that will actually tuck under that standoff that I just spot welded on the side of the elbow. Next, I am adding clips to the inside of the duct. These clips will hold the insulation in place until the glue on the backside of the insulation is dry. Here, Wyatt is applying the glue, and then he'll place the insulation and install the retainer clips to hold it in place. Next, I'm going to lay out the heel and throat of the elbow. Two sides of the heel get a 1-inch scratch, and the other two sides get a 1/2 inch. The 1-inch side is for what is called a Pittsburgh joint. A Pittsburgh joint has a little cavity that 1/4 inch that we folded up on the side of the elbow, well, it fits right into that cavity, and then we're able to fold the rest of the Pittsburgh over to seal the joint closed. I am now measuring out 35 inches to make a notch where the heel of the elbow will fold 90 degrees to wrap around the side of the elbow. I'm then going to notch out all the corners before I run it through the Pittsburgh machine. Here I am putting the side of the elbow into the Pittsburgh joint on the heel pattern. So that 1/4 inch that was bent up earlier on the side of the elbow now fits in that little cavity of the Pittsburgh, and it leaves about a 1/4 inch of metal sticking up above, which we then can fold over the side pattern, and it seals up that connection quite nicely. I am now using a pneumatic hammer to fold that little 1/4 inch over the side of the elbow. Next, I will put the throat of the elbow together, and I'll bring the camera in and you'll get a good look of what the Pittsburgh joint looks like with the 1/4 inch going into it. Rather than using the pneumatic hammer, I will just use my sheet metal hammer to finish this one off. Once the ductwork is assembled, we butter the edges of the insulation with glue to encapsulate any of those fibers so they don't get into the airstream. And here's a good look of the turning vane in the elbow. Got the 3 elbows loaded up and the other pieces of duct and the LK or high lift or high jack, whatever you want to call it, so we could boost those up on the roof. So that should wrap things up for the fabricating video. Stay tuned for the next one. We're going to take you up on the roof and we'll get that ducting installed. I hope you enjoyed this video. Thanks for watching, and we'll see you on the next one.